Hello everyone, welcome to another machine learning related tutorial by Slidescope. In the previous examples, we studied about theory of logistic regression, and in this example, we will try to solve a logistic regression problem using Python. We will use a data set to predict whether a student passes or fails on their hours of study and whether they took a preparatory course. So here you can see a data set where we have all numerical variables. So we have hours of study and preparatory course. So this is hours of study, which is a continuous numerical variable. The preparatory course is either 0 or 1. 0 means student did not take any course and 1 means student took a preparatory course. Pass 1 means student was able to pass and 0 means student was not able to pass. So this is a simple problem we have. We have simply imported pandas SPD and connected our studyhours.csv file, which you can see here. This file will be provided as a resource in the description of this video, and this notebook will also be provided as a resource. First thing is to install all the necessary libraries. So we have already imported pandas. What we are going to do is just below this, we will import numpy as np, which is numerical Python. From sklearn.model selection, we will import train test split. So we will break this data set into two parts. One, a training data set, and two, a testing data set. And this is what can be done with the help of sklearn.model selection. From sklearn.linear model, we will import logistic regression. So in the previous examples in the playlist, you have studied about linear models, linear regression class. In this example, since the output variable is 0, 1 type, it is not a continuous numerical output. We will be using logistic regression, and that is something that was explained in the theory part of logistic regression, that in those problems where output is either 0 or 1, in such cases logistic regression can be applied. In order to find the accuracy score and performance of our model, we will also import accuracy score and confusion matrix, which can be installed from sklearn.matrix, which we will understand just in this tutorial itself what they are and what is their purpose. So let's simply run this, and here all these libraries are imported and our data set is imported. Just as we did in the previous example, the first thing that we do is to break the data set into inputs and output variable. So here we are selecting hours of study and preparatory course as our input variables. You just have to provide the names properly, and preparatory course you just have to provide this entire value properly, and y, that is our output, that is whether the student could pass or not, is our output. When you will create this, x will be two-dimensional value, and this was made clear in previous examples also. Whenever you are trying to apply a machine learning algorithm, make sure your x, which is input or feature, is always two-dimensional, and y, which is your output or target, is always one dimensional. That's why we are using single bracket here to create a series and double bracket here to create a data frame. You can also check, you will write x, you will see it's a data frame, and when you will write y, You will see it's a series. Next is with the help of train test split model selection train test split, we will split the data set into two parts. What is happening here is, so we have X, that is our inputs, and it has 8 samples, and Y has it is output, it has 8 samples. When you will get an actual problem, obviously the number of samples will be a lot more. Since you have both input and output data, it is a supervised machine learning problem. Hence, what we will do is we will write it like this. So remember the sequence. You create 4 variables. First, focus on this. Okay. To apply train test split, you will create 4 variables. One is X train, second is X test. So first you will create both X's, then you will create both Y's. So X train means we will select some portion of these 8 samples for training the data, and some samples we will test the accuracy of our model. So so suppose I give you a very simple problem. When x is equal to 6, y is equal to 3. When x is equal to 12, y is equal to 6. When x is equal to 18, y is equal to 9, something like that. So what is happening here? Y is always half of x, right? So so this is our training data. Okay, what and similarly, if I ask you when x is 10, what is y? So y will be, you will say 5. Okay, so you might say it is 4, you might say it is 7, depends upon that. Might say it is 6, or the model might predict as 6. And but we will have this actual value in testing data somewhere. So this is our testing data, this is our training data. Okay, so with the help of these we will be able to predict the accuracy of the model. That's why we divide the dataset into training and testing. So that's why we split it. Now, for these 4 variables which are written in a comma separated manner, this particular class will take x as the first parameter, y as the second. Test size point 2 means we will provide 20% of the entire data set for training. We will provide, this means we will provide 50% of the data set for training. So for testing, you can also write train size here. So if you have written test size equal to zero point 0.2, that means 20% of the data set will be for training. And then we just provide some random state. So this random state can be any number, which is a random selection of variables, because let's say there are 10 samples. So 2 samples will be selected for testing, 8 samples will be selected for training. So any 8 random samples will be selected. So this random state is a number which will remember something like what samples to predict. So this way our data set will be broken into 2 parts. So when you will write X train, you will see it has 0, 3 and 3, 6 samples. Okay. Similarly, Y train will also have 6 samples, because X train and Y train will be one combination. Similarly, X text will have 2 samples, and Y test will also have 2 samples. So for these 2 samples the output is this. Okay, in this problem, since we have, this is just a very basic testing data set, so we have very less number of samples, but again when you will try it on more examples you will be able to see that you will have better results. Now since we have broken our data set into X train and X test and Y train and Y test, we will first create logistic regression model. Okay, so next step will be to fit a logistic regression model. Here we will create a model of type logistic regression, and in the model we will fit X train and Y train. So you can see that at the time of training, you will, or at the time of teaching our model about our sample inputs and output, we are fitting with X train and Y train. Okay. Let's say we want different type of sample. What if we write 12 here? And if we run the entire thing again, you will see we will have different type of samples. Now you can see different type of samples. Okay. So it totally depends upon the random state value, but every time you are changing your random state value, you have to fit the model once again. So after step number 3, fitting a model, step number 4 is to predict and evaluate. This way we will have a predicted value for X test. So for every testing value, we will have a predicted value. We can also do one more thing. Let's say we write model.predict. Inside model.predict, we will write two square brackets, and inside our two square brackets, we will provide the training data. Let's say we want to predict whether a student who has studied for 5 hours and had a preparatory course, will that student pass or not. So you will write 5 comma 1, because you have to write it in the same order. Okay, in our order, hours of study is first, then preparatory course is second. So when you will write this, just ignore this warning for now. You are getting array 1. That means this student is going to pass, because 1 means pass. What if we say this student has studied for 1 hour only? Now it will fail. Okay. What if this student has studied for 4 hours but had not any preparatory course, he did not have any preparatory course, then also that student will be able to pass. So this is what it is predicting. That's why for all X test values, which are currently two test values, a prediction is made. Now after prediction, we will print results. So accuracy can be calculated with the help of accuracy score. So you remember we had testing data, right? That we had actual values and we have predicted values. So predicted values will come from here. Actual values will come from here. Okay. Similarly, for confusion matrix, also we will use the tested values and predicted values. Okay. And when we will run this, now you will be able to see accuracy. Accuracy is 1. That means the model was able to predict it 100%. Like, because we have very less number of samples, so we will achieve high accuracy. But this is something that you have to consider. And later we will also try it on other examples. So there you will see different type of results. But this is something which is for your basic understanding. And similarly, we have confusion matrix. Confusion matrix will be an array, a matrix 1 0 0 1. Now, what do we understand from this matrix? So, the confusion matrix represent the performance of a classification model by showing the count of correct and incorrect predictions categorized into four types: true positive, true negative, false positive, and false negative. That means how many true positive and true negative are there, and how many false positive and false negative are there. So in this matrix, you can see we have four values. Okay, let me zoom it for you. 1 0 0 1. So in first row we have 1 0. In second row we have 0 1. The rows represents the true labels, that is actual classes. Row 1 has, true class is equal to negative 0. Okay, it is 1 0. And row 2 0 1, true class is positive 1. So we have negative 0, okay, positive 1. The column represent the predicted labels. Column 1 is predicted class, that has negative 0. Column 2 is predicted class, positive 1. 1 0 is row 1. 1 true negatives, that means 1 negative instant correctly classified as negative, 0 false positive. Okay, so as you can see, row 1 is true class, negative 0, and row 2 is true class, positive 1. Okay, 0 is false positive, so no negative instance. So in row 1 we have true negative, 0 false positive. In row 2 we have 0 false negative and 1 true positive. Okay, so it is how it behaves. So we have 1 true negative, 1 true positive here. So what is the summary? We have 1 true negative, correctly classified 1 negative instance, 1 true positive, correctly classified 1 positive instance. No errors, no false positive or false negative. The overall accuracy of the model in this case is 100%, as all predictions were correct. Again, this may be confusing because its name is confusion matrix, but when we will learn more examples, this thing will become clear to you. Obviously, this is a very small example. So here you can try to ignore confusion matrix also, but later in we will try to do a problem with digit recognition system, where we will try to find out what is the meaning of this. Okay, so this is a very basic example of logistic regression on hours of study versus pass or fail data. And similarly, it can be anything like age of person and whether the person will buy insurance or not, or buy something or not. It can be age of person, number of hours spent on the website, and bought a product or not. So let's say age of person is 22. That person is spent 10 hours on our website. So on an average, those people who is spent 10 hours is a very big number. On an average, those people who spent more than 1 minute on our website were likely to buy something. So based on this, we will be able to find out who is our targeted audience, what is their age, and later you will also learn different type of classification algorithms where you will be able to find your targeted audience. So application of logistic regression is can be anywhere where we have a data like this. So just try this example and see if you are able to find correct answers or not. You can create other sample values here to check something from yourself.